We all know that saying, right? A picture is worth 1,000 words.
Mm-hmm.
But when we get into design visualization, it's it feels like more than just looking. It's
Yeah.
like you have to read the picture to really get the insights.
Absolutely. Yeah, think of it less like just making things look nice and more as a fundamental language.
Well, language.
Yeah, for communicating really complex ideas, maybe showing how a process works, or even, evoking certain feelings visually. It's about
Right.
clarity, impact.
And it covers so much ground. I mean, from those really quick, rough sketches.
The napkin drawings.
Exactly. All the way to like super detailed 3D models and animations.
Yeah, the whole spectrum.
And for this deep dive, we've got some great material. There's a lecture, really insightful, and also some briefing docs that boil things down.
Which is a perfect mix, actually. You get the flowing explanation and then those core takeaways, right? Let's just dig into the why behind it, not just the what.
Okay, so our mission today basically is to give you a shortcut, a way to really grasp the main ideas in design visualization.
Without getting totally overwhelmed.
Exactly. We'll pull out some surprising bits, practical stuff, keep it clear.
Yeah.
So where do we start? The technical basics.
Yeah, let's start there. The fundamental rendering process. It usually kicks off with importing 3D models, from software like 3ds Max, Maya, SketchUp, things people might know.
Right, getting the digital objects into the scene.
But here's the thing. A step that sounds small but is huge is unit setup.
Unit setup, like measurements.
Exactly. Getting the scale right from the absolute start. It's crucial. Think about it. If your units are off, if one brick is slightly bigger than another.
Nothing fits. Like your house analogy, it just wouldn't work.
Precisely. It's not just aesthetics. It breaks things later. Light won't react properly. Textures look weird. It cascades.
Okay, so units first. Super important. Then what?
Then mesh optimization. Your 3D models are made of loads of tiny polygons, usually triangles.
Right, the building blocks.
Sometimes you have way, way more than you need, makes things clunky, slow. So optimizing is like cleaning that up, making it efficient.
So the computer doesn't grind to a halt trying to render it all.
Exactly. Especially on complex scenes, it can genuinely crash systems if the mesh is too heavy. It's about efficiency.
Makes sense. Keep it lean.
Eh.
So after the cleanup, things must start getting complicated.
They can, yeah. Which is why organization is key. Grouping things together, maybe all the chairs or the exterior walls.
Or using layers.
Like in Photoshop.
Yeah, very similar.
Yeah.
Separate floors, maybe interior versus exterior. It just makes managing a big project so much easier, like having, tidy folders versus a messy desktop.
You can actually find things. Okay, so you've got your organized objects. Then you need to give them context.
Precisely. Landscaping, trees, plants, other stuff like cars, people. They're not just decoration. They are vital for scale.
Ah, right, to show how big the building actually is.
Yeah, one of the sources nailed it. What is important about this object is that it first gives us scale. You see a little figure next to a huge structure.
Instantly get it. Like seeing a person in a photo of a mountain, suddenly you grasp the sheer size. Exactly that feeling. And building on that scene setting, the camera is, it's our window into that world.
How we see it all.
And that's where this idea of mise en scène comes in. It's a film term, really.
Mise en scène.
It's about everything in the frame. The layout, the mood, what the camera captures. There's a great book, Understanding Movies, that talks about it a lot. Surprisingly relevant.
So it's not just point and shoot. It's crafting the view to tell a story about the design.
That's it, perfectly. The camera position itself is often the starting point. The sources mention different framing types, open frames feeling vast, closed ones maybe more claustrophobic.
Static versus dynamic.
Right. Static feels stable, dynamic implies movement.
Right.
Even using strong lines, diagonals, circles guides the eye, changes the feel. Diagonals often add energy, maybe tension.
Like those action movie shots, yeah.
Yeah.
Makes everything feel intense.
Totally. And just like using people for scale, thinking in layers, foreground, middle ground, background, builds that sense of depth, makes the space feel real.
The penguin example again.
Yeah. By including this one penguin, we instantly feel the scale. That little guy up front makes the ice field behind feel enormous.
It's amazing how our brains process those visual cues.
Yeah.
And the lecture mentioned camera angle too. Low versus high.
Oh, hugely important. Angles really shape emotion. Look up from a low angle, things seem grand, powerful, maybe a bit intimidating.
Makes the building look imposing.
Exactly. Shoot from a higher angle, looking down slightly. It can make the subject seem smaller, maybe more vulnerable. It's a core storytelling tool.
Okay, scene set, camera placed.
Yeah.
Now for the realism, right? Lighting and texture.
Yes, and they are so tightly linked, especially with modern rendering, GI, global illumination.
Yeah.
Yeah, it simulates how light really bounces around a scene. Much more realistic shadows, ambient light, but it means your textures, the materials on the surfaces have to react correctly to that light.
So sunlight hitting wood looks different than, say, soft indoor light hitting the same wood.
Absolutely, the texture needs adjustment. And crucially, as one source said, specifically, lighting and texture differ depending on the angle you view them from.
Ah, so how light reflects changes depending on your viewpoint.
Exactly. That interplay is what makes it feel convincing, immersive.
And then, even after the computer renders it all out, there's another step. Post-production.
That's right, the final polish. Kind of like using Photoshop on a photo, but often with software like After Effects for images or animations.
Refining it.
Yeah, and a key part is using rendering channels. Think of them as separate layers for like just the reflections or just the shadows or just the shiny bits.
So you could say, make the reflections on a window brighter without re-rendering everything, which takes ages.
Precisely. Huge time saver. Gives you amazing control. The lecture mentioned blending modes too, like screen or add. Really useful for tweaking lighting subtly in post. It often takes a rendering from good to great.
Okay, so that covers static images, but visualization is also about movement, right? Animation.
Yes, animation just adds that time element, showing change, movement. The main principle is keyframing.
Keyframing.
You basically define the state of something, its position, size, rotation, even color at specific points in time. Start here and there.
And the software fills in the gaps, like a digital flipbook.
That's a great way to think about it. And you can use it for loads of things. The lecture showed building construction visualization.
Right, showing how it goes up piece by piece.
Yeah, controlling visibility so parts appear in sequence, or showing the assembly step by step, or even slicing through the building over time to reveal the inside. Really powerful for explaining complex sequences.
Definitely clears things up.
Yeah.
Now, how is simulation different from that kind of direct animation control?
Simulation is more about setting up an environment, defining rules, and letting the system figure out the result.
Less hands-on control.
Kind of. You set the physics, the forces, the constraints, and the simulation runs. Like using Voronoi diagrams to make realistic cracks, you define zones, it calculates the fracture. Or character animation using rigging a digital skeleton in motion capture. Or particle simulations for things like smoke, fire, water, dynamic stuff.
So animation is direct instruction. Simulation is setting up the scenario and seeing what happens.
That sums it up really well. And the lecture, it didn't just talk theory, it showed amazing real-world examples of all this.
Oh yeah, that was great. Seeing it in action, like the commercial examples, the Nong-Ive and Hannah Bank construction.
Showing the dust control with water during demolition.
And the phase construction near the subway. Visualizing those complex logistics, solving real problems.
Totally. And the Songdo Central Park visualization showing the public what that space would feel like before it existed.
Then there was the design stage stuff, sketches, storyboards, rough animations just for the team.
Crucial for developing ideas internally, yeah.
I really like the exhibition examples. That Evelo competition entry shown in a virtual gallery.
Or that undergrad design from '05, how showing the exhibition space itself helped convey the idea. Context is everything.
And the grad school project looking at spatial character, more abstract uses.
Yeah, not just realism.
Yeah.
Then the interactive stuff.
Yeah.
Those light strips reacting to people walking in Gongwamun or San Francisco.
Data-driven visualization responding in real time. Very cool.
And that interactive roof trike in popular spots. Silas Shinya's work at ETH, I think, used in a Cambridge library.
Helping kids, yeah. Shows how visualization can become an interactive interface, not just a static picture.
Definitely. We also saw fabrication visualization, that bent chair rendered to look like it was actually on site.
Blurring digital and physical made it feel real, tangible.
And interactivity again with the Connect at Sydney Opera House, turning the facade into a digital notice board.
Architecture as a communication platform. Wild.
Then the Sensible City Lab's traffic algorithm visualization, using visuals to understand and maybe even fix complex city problems like traffic jams.
We also brushed on film stuff, blue screens, green screen.
Standard background replacement, yeah. And motion tracking sticking digital smoke onto a moving car or stabilizing shaky footage.
So many tools. The lecture mentioned plugins too, like for growing
An
trees.
EB generator, yeah.
Yeah.
And how 3ds Max has this huge library of plugins, even more than Rhino Grasshopper, just because it's been around longer.
And exporting animations directly from parametric tools like Grasshopper.
Makes complex forms move, even simple things like the markups showing different chair patterns,
Yeah.
effective communication.
It's always about picking the right tool, the right visual language for the idea, like that coat hanger pavilion project in New York.
The AIA project link, yeah, showing structure, potential use, all visually.
And finally, the immersive side, VR, AR, using things like Unity.
Right, that exhibition example using light was powerful. Dark room guiding you with light.
Contrasting architectural and organic shapes.
And sound design being crucial too, creating a whole sensory experience, not just visual. Really impactful.
Absolutely. So, wrapping this up,
hmm
what are the big takeaways for you, for the listener?
Well, for me, it really comes back to that idea of reading images, not just seeing them. That's the core, I think.
Yeah, a good visual can cut through complexity like nothing else.
And understanding the principles, composition, light, animation basics, that's more important than knowing one specific piece of software. Those ideas travel with you.
It really feels like this meeting point of tech skill, design sense, and storytelling.
Totally. And it's always changing with VR and AR pushing things further.
The recommendation to check out film resources like Understanding Movies for composition ideas was interesting too.
Definitely borrows from that visual language. So yeah, we've covered a lot, hopefully giving you that shortcut to the essentials.
Understanding these fundamentals gives you a lens, right, to both understand and create visuals, whatever tools you use.
Exactly.
So maybe a final thought to leave people with, as these visualization tools get easier for everyone to use, how does that change things?
Yeah.
How we communicate, how we understand complexity.
What new possibilities does that open up?
Definitely something to think about. Maybe check out that book or just play around with some basic tools.
Because visual communication in this complex world, it's only getting more important.